Section 1.5 talks about the graphs of tangent, cotangent, secant, and cosecant. The good news, if I want to use secant and cosecant, I already know how to graph that. To sketch a graph of y equals secant, you really want to look at y equal cosine of x. So we're going to graph this. Well, we know how to graph this. We're going to go up a unit, down a unit. That's the amplitude. The graph of a cosine starts at the amplitude, runs down, back up. In this section, I'd like you to sketch a graph to the left and to the right as starting point, so we want two periods. There's one, there's another. I do my labeling. My period is 2 pi. 1/4 of that, this is pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, and negative 4 pi over 2. Keep in mind, I'm looking at a graph of a secant, which is 1 over the cosine of x. Wherever the cosine of x equals 0, it's undefined. That's called an asymptote. So wherever the graph crosses the x-axis, that's an asymptote. There is one point in which both a fraction and its reciprocal are equal, and that's only at x equal 1. And where does that happen? That happens at x equals 0, cosine of 0 is 1, and secant of 0 is 1. Or, look at that. It matches right there on the amplitude. And the graph really looks like a bunch of parabolas. In this interval, when you have pi, cosine of pi is negative 1, and 1 over negative 1 is negative 1, or simply, it's going to match the original graph. Wherever the original cosine touches the amplitude, the secant matches. That's an included point. And it always heads toward the asymptote, like you learned in rational functions. And there it is. Now, I do want to point out, this part is for reference. The back of the book doesn't have this. They have it listed literally the way you see it. You could leave it like that if you wish, or you could leave those on. I can care less. So, secant and cosecant, that's how we graph them. Basically, if I want to graph y equal negative 3, the secant of pi over 2x, I'll say I'm going to really look at y equal negative 3, the cosine of pi over 2x. So these graphs we already know how to do. 1, amplitude is 3, 2, period is 2 pi. Instead of dividing by pi over 2, I multiply by 2 over pi, that's a 4. 3, none, 4, none, 5. There's a negative, so we're going to reflect. And if I look at the graph of one, 2, 3, 1, 2, 3, you label those clearly for me. Y equal a 3, y equal a negative 3. The graph of a cosine starts at the amplitude, but if it's reflected, I need always 2 cycles in this section and the next section. Oops, missed it. And if I remember correctly, wherever the graph crosses the x-axis, oops, that's an asymptote, because wherever the cosine equals 0, the secant is undefined, and similarly, wherever the sine equals 0, the cosecant is undefined. The graph really consists of wherever the graph touches the amplitude, that's the common point, so it's the green part. So it looks like a bunch of parabolas. Everything in red is just for reference. I forgot to label. That's why I do that red. If I take 1/4 of the period, isn't that 1? That is 1, 2, 3, and 4. Negative 1, negative 2, negative 3, and negative 4. And there it is, one full graph with 2 cycles. And if I look at number 36, the same deal. I'm really going to look at the graph of y equal the sine of 3 pi over 2x. So 1 amplitude is 1, 2 the period is 2 pi. Instead of dividing, I'm going to multiply by 2 over 3 pi, so that's 4/3. I would go ahead and put the original grid. I would move up 1 and down 1. And a graph of a sine wave starts at the origin, runs up to the amplitude, back to the starting point. I need 2 cycles of each of those. So the book really eliminates those completely. Some teachers like those dotted, I don't mind. Now, wherever the graph crosses the x-axis, those are asymptotes, because cosecant is undefined wherever the sine is 0. And the same, they match. That is, amplitude is really the key point, left to right. This point is common, and you head toward the asymptotes. Matches on the amplitude and head toward the asymptotes. Matches on the amplitude and head toward the asymptotes, and there it is. And that's 2 cycles of this. So you're going to regraph what you did already. Now tan and cotan are slightly different. The only difference between what we did and what we're doing right now is you take pi divided by b. Everything else is the same. And if we look at a graph of a tangent, again, if I pick points for tangent, I'll notice how this works. I know that at 0, tangent of 0 is 0. Pi over 4, tan of pi over 4 is 1. And at pi over 2, I know tan of pi over 2 is tan of pi over 2, if you think about it. Sine over cosine, it's undefined. That will all come up in this. I start at 0, and it looks like a cubic and minus a cubic. And it runs between pi over 2 and negative pi over 2. Cotangent, unfortunately, doesn't do what you would expect. That is, wherever tangent equals 0, wherever the tangent equals 0, cotangent is undefined. Wherever tangent equals 0, it's undefined. And wherever tangent is undefined, this is 0. Because it will be, at this point, it will be the cosine over the sine. So, I'll show you how that works. I'm just showing you how to pick points. We're not going to pick points, of course. Cotangent runs between 0 and pi, and it looks like a negative cubic. So, if you remember this, the labeling I'll show you how to do. And since there's only a half a period, not 1/4 for tan and cotan. If I look at number 18, 1, amplitude is a negative 2. Amplitude doesn't mean much for tan. I'll show you what it does. 2, period is pi divided by 1, so it's pi. And negative, we're going to reflect. That's number 5. So if I look at the graph, this is really how it works. Sine and cosine have 4 equal parts. Tan and cotan only consist of 2 equal parts. That's it. So, if I look at a tan, well, tangent, I know starts at the origin, and we need half a period. Half of the period is pi over 2. So it's going to take pi over 2 to the right, and pi over 2 to the left. The graph of a tan looks like a cubic, but since this is reflected, it's going to be backwards. It's going to look like this. this is pi over 2, and this is negative pi over 2. If you decided to graph another period, you can. We moved 4 units, 1, 2, 3, 4. You could graph as many as you like. You just mimic that graph. It's really simple. And once you have that value, once you have 1/2 of the period, you get all of them. If this is 1/2 of the period, this is 2 halves, 3 halves. There you go. You can move to the right, to the left, it doesn't matter. So amplitude doesn't really limit much because it's going to run to infinity and negative infinity. If I look at number 22, 1, amplitude is 1, 2, period is pi divided, instead of dividing, I'm going to multiply by the reciprocal, it's 2 pi. So if I sketch a graph of this tangent, well, here it is. It's going to start, it's not shifted, it's going to start at 0. I'm going to take half of this, which is pi. 2 units, and 2 units. I always go 2 units. And tangent look like this. All the graphs of tangent will look identical to this. Labeling would be different. This is pi, which means this is negative pi. If you want to sketch another period, well, all of these are equidistant. Once you figure out what this is the same, this is the same, this is the same. So if this was 1 pi, this is another pi, 2 pi, 3 pi, there it is. Really simple. And if I decided to give you an example, because there aren't enough in the book, 1, amplitude is 3. 2, period is pi divided by 7. And 3, we don't have any. 4, we don't have any. 4 we do. We have a vertical shift of y equal 2. Notice how this plays. It's really very simple. They all work out the same. I'm going to go to my shifts first. Y equal 2. One, 2, and I label that clearly. Y equals a 2. I am going to expand that a bit. There. Now, and I'm going to expand that even a bit more. Okay, y equal to 2. Now you notice, I'm going to take the origin. I'm going to run 2 units to the right, 2 units to the left. And I can tell you what the graph looks like. That's easy. Graphing is the easy part. Labeling is the hard part. I can even give you another graph. Those look exactly the same. All what I need is to figure out what is 1/2 of this quantity. Isn't that pi over 14? Done. If that's 1 pi over 14, that's another, that's 2 pi over 14, 3 pi over 14. To the right you add, to the left you subtract. And there it is. A bit of addition and fractions and you're done. That's pretty much it. If you go for a cotangent, the same deal. 1, amplitude is 1. And I'll tell you what amplitude does when we get to the next section. 2, so it doesn't really show on the graph as much. It affects the shape. Period is pi divided, instead of multiplying, I'm going to divide by 4 over pi, which is 4 units. Tan, unlike cotangent, cotangent unlike a tangent, and vice versa. A cotangent labels the starting point as an asymptote and moves 1, 2, 3, 4 and an asymptote, and 1, 2, 3, 4 an asymptote. That doesn't look like an asymptote. And graph of a cotangent is like a negative cubic, so it looks like this. And that's how they all look. And the same deal. What is 1/2 of 4? That's 2 units. Once I know this is 2 units, guess what? This is another 2, another 2, another 2. And if you want to move to the left, you can. In case you're wondering how come he always moves to the right. If to the right you added 2 units, to the left you subtract 2 units. And that's all there is to it. And the last problem, 1, amplitude is 3. Again, I'll tell you what amplitude does in the next video. Period is pi divided by, instead of dividing by 1/2, I'm going to multiply by 2/1, which is 2 pi. 3, we have none. 4, there's a vertical shift of y equal a -2. So if I sketch this original grid, expand it a bit, I'm going to start with my shifts. There's a shift of -2, -1, -2. Label that clearly for this guy because he's picky. And how does this work? Well, I know how a cotangent looks like. Cotangent is going to start at the origin, being an asymptote. And we're going to run 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. 3 full cycles for you. It is a normal graph, so basically halfway through, everything with tan and cotan is half a period apart, and all what I need is to figure out what a half of this is, which is pi. Once I figure out that this is pi, another, subtract, and subtract another. And there it is. That's all there is to it. And there's your homework.